Hi, hello, and welcome to this video, the first out of a few videos in which we'll go over the basics of trigonometry. So let's go to the file. We'll go over some basic definitions that we'll need later on. Here's a definition of an angle as the amount of rotation between two straight lines. We'll use the letters alpha, beta, sometimes theta, x, and other letters to denote angles. Another term that will be important to us is an arc, because we will look at circles. So the total perimeter of a circle is called the circumference of the circle. An arc is a part of the circumference, and we denote arcs using the angles they subtend. It goes like this. If we take this arc, for example, let's call it arc A, or this arc, that we call this one B, we define them using these angles. This arc A subtends this angle, let's call it alpha. And this arc B subtends this angle, let's call it beta. And so we can write that arc A subtends angle alpha, or angle beta is subtended by arc B. We will now talk about measuring the size of an angle. One of the measures is degrees. I'm sure you're familiar with degrees. This is where we divide the circle into 360 degrees. Why 360? You have an explanation here, mostly because it is convenient. We actually divide the circumference of the circle into 360 arcs, each subtend an angle that we call 1 degree. You can see here the closer loop with the little arcs and the angle of 1 degree. Let's see some examples of angles, and to each angle we will match a point on the circumference of the circle. Our reference point will be this point on the right side. This will be considered as 0 degrees. So for 90 degrees, which is this angle, we will match this point. 180 degrees, half a circle, is represented by this point. 310 degrees is around here. The matching point is this one, and so on. 251 is around here. This is the matching point. 50 degrees is here. 165 is around here. So each angle is represented by a point on the circumference of the circle. We will see here that angles can have the size not only between 0 and 360, but also above 360, because we can keep on rotating more than one full circle. 380 can be written as 360 plus 20. We make a full circle of 360 and then another 20. So this point match 380 degrees. 500 is 360 plus 140. So it's this angle, 360 plus 140. Matching point is here. 920 is 2 times 360, that's 720, plus 200. So we make 2 full circles and another 200. This point match 920 degrees. We can also have negative values for angles. We define a positive angle when the rotation is counterclockwise, like we did before. When we rotate clockwise, the angle is negative. Here are some examples. Minus 90 degrees means we rotate clockwise 90 degrees, and we get here the matching point is this one. Minus 180 means we go here, that's the same point as plus 180 because it's half a circle. Minus 270 is 3/4, matching point is here. And so we have for minus 40 around here, minus 100 is around here, just a little bit after minus 90, and minus 200 should be somewhere here. So you see that we can have any value for the size of an angle, not only between 0 and 360. Next, we will look at the fact that each point on a circle matches more than one value, because when we make a full rotation, we get to the same point with another value. This point, for example, matches 0 degrees, but when you make another circle, it's 360, and another one, it's 720. Or we could go to the negative direction and get minus 360, minus 720, and so on. We write it as 0 degrees plus 360k, or minus 360k, where k is actually the number of rotations we make to get to the same point with a value that is increased or decreased by 360 degrees. You can see other examples here. And let's summarize what we saw in this video. An angle is the amount of rotation. We talked about the first measure of the angle, which is degree, where we divide the full circle into 360 degrees. On the next video, we will introduce another measure for angles. The size of an angle in degrees is not only between 0 and 360, it could be actually any real number. And we saw how to match or represent any angle as a point on the circumference of a circle relative to a reference point that we took as the point at the right side of the circle. So, see you on the next video where we'll introduce the radians.